Concept getters, how are you? I hope everything is going well and that you are enjoying your year so far, and the June exams and the final exams that are coming, you're gonna ace them. Okay, so when you look at this is proving identities. We have sine x over 1 plus cos x is equals to 1 minus cos x all over sine x. When you look at this question, you realize that it is different from all other questions that you have seen, because here there is no complicated side for you to simplify, right? So when you see something like this where either left-hand side or right-hand side are not complicated, just choose any. But here in this video, we're going to do both to show you that it is actually easy either way, right? So we're going to start with the left-hand side. So when you choose the left-hand side, let's just choose it, right? Let's say you choose the left-hand side. The left-hand side, remember, it's going to be your sine x over 1 plus cos x. There's something that you have to do. You rationalize. To rationalize is to multiply by something that is going to be 1. We call it introduce 1. So I'm going to write it here as a concept. When it comes to this type of question, the concept is you have to introduce 1. In a sense of what? In a sense of rationalizing. So when you rationalize, what do you choose in order, like what is it that is going to be your 1? You look at what you are trying to prove. Remember, we are choosing this side. So you look at the side that you are proving on the other side. Since we're going to simplify this, you look at this side and you look at its denominator. You're going to introduce this denominator over itself. So that's what you're going to introduce. Okay, so you go to your question, you say, oh, I will introduce sine x over sine x. You look at the denominator of the other side that you are not proving, that you're proving towards, and then you say that denominator over itself. This is similar to 1 because when they cancel each other, it's 1, right? So that's why I'm saying you take that 1 and you divide it by itself, and then this is similar to multiplying by 1. That's the trig part. Then when you have something like this, then you multiply. Don't cancel, you just multiply out. Let's see how it goes. So you're going to say, oh, the next step is going to be what? Then you multiply them. Remember, when you multiply fractions, this multiplies this multiplies this. But guess what? In your denominator, do not distribute. All the time, do not distribute. Leave this binomial as it is and leave this as it is, so that at some point something will cancel this one, so that you'll be left with this one, so that you can have this in your answer. You'll see as we simplify. Okay, so you're gonna say sine times sine at the top there. Sine times sine is sine squared x at the top. At the bottom, you have what? You're gonna have sine x into 1 plus cos x. I know someone will be like, why can't I just do this, Mr. Sir, and distribute? Don't. Why? Because we want our sine x to still be here at the end so that it can be this. That's what we are looking for, right? So we are working towards cancelling this. So you realize, well, no, man, at the top here, this is what I can simplify now. If I simplify sine squared based on identities, sine squared x is what? Grade 11 identities is going to be what? 1 minus cos squared x. Tell me if I'm wrong. Then you have sine x into 1 plus cos x. Clear? Then what do you have now? Remember now, when you look at this, 1 minus x squared, this is difference of 2 squares. So this is the same as 1 minus x into 1 plus x. Difference of 2 squares algebra, you're going to factorize, right? So you follow the steps of the other ones that I've done already in trigonometric identities. So even this one, you're going to apply difference of 2 squares and factorize the numerator. So you're going to have what? You're going to have 1 minus cos x into 1 plus cos x, and you close all over sine x into 1 plus cos x, right? Then you close. Then you realize, oh, now I can cancel 1 plus cos x and 1 plus cos x, which means at the top I'll be left with what? I'll be left with 1 minus cos x. And at the bottom, I'm going to be left with sine x. Isn't it this one? It is. They are similar. So then you're going to conclude and say left-hand side equals to right-hand side. You see how easy this is? Now let's see if we were to prove the right-hand side. If we were to do this so that we can have this, how is it going to do? The same principle, you introduce 1, but let me rewrite it. Let me say you had 1 minus cos x all over sin x, right? Remember, I say you introduce 1. 1 in what sense? In the form of the denominator of what you are proving towards, right? So you're going to introduce 1 plus cos x over itself. So you're going to say, I'm introducing 1 plus cos x over 1 plus cos x, right? And remember, do not distribute the denominator afterwards. Keep them the way they are. Only deal with the numerator. Clear? So the next step, you're going to say what? You're going to say equal to what? 1 into 1 is going to be 1. And then into cos, you're going to have plus cos x. And then minus cos x. And then minus cos squared x. Basically, it was like this, right? You are multiplying 1 into 1, 1 into this, cos into 1, cos into this, distribution, clear, of binomials. And then I'm going to have that. Then in your denominator, you keep it the way it is. You're going to say sine x into 1 plus cos x. So your next step, you realize that your middle terms, the 2 terms in the middle, second and third term, cancel each other. We call them additive inverses, right? So you're going to be left with only 1 minus cos squared x. Then it's going to be all over sine x into 1 plus cos x. Clear? Now, if I'm proving this to get this, I need to eliminate sine, right? So in order to eliminate this sine here, I have to introduce sine at the top. How can I get a sine? Identity, grade 11 identity of sine squared. So we all know that 1 minus cos squared x is sine squared x. So at the top, I'm going to write what? I'm going to say this is the same as sine squared x. 1 minus cos squared x is always sine squared x. Then we say all over sine x into 1 plus cos x. So we know that when you have sine squared x, this is the same as what? Sine x times sine x. One of the sine x's will cancel this one. You're going to be left with 1 in your numerator. So when you have sine squared x, it means you have sine x times sine x. The exponent tells you how many times the base multiplies itself, right? So this squared here tells you how many times or how many sine x's are there multiplying each other. So which means we have 2 sine x's at the top there. One of them, right? Just one of them cancels this, which means at the top you'll be left with only 1 of them because it was 2, and at the bottom, because at the bottom you only had 1, it's over, it's eliminated. You're only left with 1 plus cos x. When you look at this, it's this. So you proved it. Therefore, you're going to say, therefore, your left-hand side equals to your right-hand side. Come on, guys, don't tell me this is not easy. I did 2 methods in less than 10 minutes. Remember, you have to do this for other concept getters out there. For YouTube algorithm, you're going to subscribe so that you can see more videos and share so that you are not the only person who passes. We are fixing the country. And you're going to like if you really liked it, of course, and comment because you want to engage. You want to tell me something, tell me which ones to do. And anyway, yeah.